define it to be trainable. No question. So the next step here is exactly the same as what we have done in the previous step, which is defining the classifiers. Yeah, because what we are trying to do here is relaxing some feature extraction layer and also retrain our classification model. Okay. So in the demonstration code that I provide, I'm using the exact same classifier. Okay, so that our model performance is comparable. Yeah. So once we load the base model, we can do a few things. For example, we can visualize how our network look like. There are two ways of visualizing our network. First one is to use the dot summary, where it gives us a tabular format of preview. So from this summary table, we are able to get all the numbers of parameters that we are trying to learn from this network. So we can also use this plot model to give us a graphical representation of the entire network. So this is how the entire VGU16 look like. It is very straight and linear. In the case where you visualize a ResNet, it will be very beautiful. Okay. Okay, so yeah, we have just done how do we load the model? How do we load the blank model? How do we load model with pre-trained weights? How do we load models and unfreezing certain layers? Any questions so far? No. So next step is compiling a network. I believe that we have already covered this in week 5. In compiling network, we need 3 things. We need to define the loss function and the matrices which the network will use to evaluate as the training progress. And we will also need to define the optimizers. Optimizers is specifying how this network should learn and how fast it should learn using the learning rate. So you are supposed to experiment on this learning rate, yeah, and see what is the effect. Okay, so once we have compiled the network, we will then be able to train the model. In terms of training a model, I believe we have covered everything that we need to know. So we will be fitting our model, the predefined model, the network, as well as the compilation to our training and validation data set. And we will have to define our epoch. So as the training progress, we are trying to see whether this loss function reduce over time and this accuracy should improve over time. Yeah. And because these values is a little bit hard to visualize, therefore, we will put all these values into a graphical format. So the first evaluation that we need to take on is to evaluate how the network performance. So network performance is evaluated using this graph. So from this graph, what we are trying to say is whether our network has is overfitted or not overfitted. So in this case, what we can see is this network is not overfitted because the training accuracy and the validation accuracy is very close together. And we know that if we were to improve the epoch of the training further, there is still room for this model to improve. Yeah. Currently, it is seeing about 65% of accuracy. And if we were to train it a little bit further to 50 epoch, the accuracy can still be improved. It still has not plateaued off. Yeah. So then that's just in terms of evaluating the network performance. So what do we do next is we will save the model in a H5 file format and then retrieve the weights or retrieve this model and apply it to our testing images. So once we apply it to our testing images, we'll be getting a set of predicted labels. So once we have the predicted labels, we will then be able to compare it to our actual labels. Yeah. So once we have the predicted and also the actual labels, we will then be able to quantify the performance in the format of the performance matrix, confusion matrix. How many % of cats images is predicted correctly? How many dogs images is predicted correctly? And what is the accuracy of the predictive power? Okay. So now That's all I want to share today. So there is a task for you to do after this class. So I have provided the code for 3 models, on 3 separate notebook. So what you need to do is to analyze the CNN architecture between the 3 models. So put them into a table format. Analyze the compilation configuration here of the 3 models. Evaluate the network performance, that is 3 of this graph. You do not have to rerun the code because it's going to take some time. What you need to do is just to take some screenshots and analyze this. Okay? Analyze the network performance in terms of accuracy and loss. Put them into a table format. Evaluate the predictive performance, which is this one of the 3 models. Okay? Sounds good? Okay? Yeah? So we shall dismiss the class today. And I'll see you week 9. Happy holiday.
Without my brain,
Yes, Monday 8 to 10. Yeah? So now for your assignment, I do recommend you to follow this structure where you will pick 2 architectures. Yeah? So after picking the 2 architecture, try to train one architecture with this blank architecture without pre-trained weights. And then do 2 transfer learning. So the first transfer learning, you will retrain the classifier. And the third model, you will also use transfer learning. You will retrain the top layer of feature extractor and retrain the image classification layers. Okay? And that will do. Yeah?
Betul, right?
Yeah.
Yeah.